Awesome. This room is a little big for us, but I have to admit the sound is great, really great. So welcome everybody. Welcome to my talk about Eclipse Xpect. It's about easy specification, review, test, and testing of Xtext languages. My name is Moritz Eisold. I'm one of the founders of the company Typefox. And actually, Xpect is a project that has been around for a while on GitHub and has been used in a pretty large number of public and internal, internal at a variety of companies, Xtext projects. And the big news today is that Xpect has become an Eclipse project. So at the time when I wrote the proposal for this talk, it was just a proposal for the Eclipse project, but by now it has been accepted and the IP review went through, and the initial contribution is in the Git repository, and currently we are working on actually making the first build, the first release available of Xpect under the new namespace, which will not be org Xpect anymore, but org Eclipse Xpect. And to give you an example of one other Eclipse project, which is making very, very intense use of Xpect, which is the N4JS project. Here we see a screenshot of them running around 6,500 Xpect tests, which is just a small fraction of what they actually have in their project. But to introduce Xpect, let's take a step back and and see, or no, right, no. Sorry, I mixed up one slide. So to go, or before I go into Xpect tests, let's talk about some qualities that tests should have. That doesn't only apply to Xpect, that in fact applies to all kinds of tests. So it's pretty critical that they run fast, in my opinion, because as a developer, sooner or later, you're in a position that you need to run the test locally, to try it, to debug it, and yeah, I can tell you guys are expensive. So if you sit around waiting for a test, it's not a good thing. So it's much better when the test is running fast. It should be really easy to and really fast to actually create a test, and so there should be good tooling to create tests. And tests should be very simple. They should be self-explanatory. They should be self-contained. I mean, being self-contained really helps to understand them, because if the tests or the things that are relevant for a test are scattered all over the place, then yeah, then it's really hard to find them, which means it's really hard to understand what the test is actually doing. And even better, when the tests are really, really simple, then it becomes possible to actually involve domain experts into reading the test, discussing the tests, and maybe even writing the tests. And by domain experts, I mean those people that know the domain and are involved in using or creating the language, but maybe have no knowledge about Java or how to build an Eclipse plugin. And another nice property of a test, when a test fails, the test should tell you why it failed. I've seen so many JUnit tests that failed, and they said, yeah, it was true, but I expected false. What? Or so then you need to start reading all the code, and slowly you understand why it was. So it's nice when the test tells you a little bit more about what really went wrong. and along with that goes, tests should not fail prematurely. I mean, we probably have all seen those JUnit tests that make use of assert like 5 times in a row, and the first assert statement fails, which means the other 4 are never executed, which means when the test fails, you do not get a complete damage report. You only get a first, or a pointer at the first problem. And right, that shouldn't happen. And right, but let's get a bit more specific about Xpect and look at how it all started. So a few years ago, I was involved on site at a customer, and we were designing a domain-specific language, meaning I was talking to many people who wanted to use those languages, and everybody contributed some parts of their very specific domain knowledge. And I was the guy sketching grammars, shaping examples, and trying to explain those examples to the people. So I ended up showing the examples in meetings, but also sending them around via email, pasted them in PDF, because this way I could easily preserve syntax highlighting. And since it was written communication, I still needed to do the explaining part, but also in written form. So I ended up introducing a lot of comments into those examples, comments that would illustrate what was my attention and what did I expect in this certain scenario, like I expect this to work, I expect this to fail, or I expect this to behave in a specific way. And yeah, then as the project progressed, we needed to create many test cases, but we already had all those examples. So the idea was pretty reachable for us to just, why don't we take those examples and make the comments that we already have in there executable. And that was several years ago, and the result of this is what we find now in Xpect. And so here I have, sorry, yes. Here we go. So I would like to demo Xpect. And in the first part, I want to use tests that I've wrote for the domain model example. So the domain model example is actually an example that ships with Xtext itself. And yeah, I wrote a bunch of tests for it in Xpect. And now I want to open such a test. Actually, the domain model example is installed in my host Eclipse here right now. And so now when I look at this file, now I open this dmodel is the file extension of the language that I'm testing. And now I opened it in the dmodel Xtext-Editor. So this is just when you develop a language, this is the editor that you are in fact developing. And since this is the editor, everything works just as you would expect in an Xtext-Editor. And now we see that here, inside this editor, there's a bunch of comments embedded. Like we find expect setup, here we find expect something, and so on. And this is now the Xpect language that like integrates with the language that we want to test. So you can say we have one file or one document, and in there are 2 languages, and they don't even know about each other. Because the deal is, I mean, the language that you're developing, for that language, the deal is that it supports comments, and the language should not assume what's inside a comment. So in the comments, there can be any kind of content. On the other way around, Xpect assumes that it only parses what's followed by an expect statement, or what's followed by an expect setup statement, and Xpect will ignore everything around it, which means it ignores all the other stuff here in between. And For Xpect, of course, there's another Xtext-Editor. So when I open this one in the pure Xpect-Editor, then it will look like this. So there's that we get syntax highlighting for the Xpect keywords and also content assist for all the tests that we could call. But since we don't want to choose between use my my very own editor or use the Xpect-Editor, there's also a third editor which combines both languages. So this is a that's a generic editor, or actually it's a slightly customized editor of what of the language that is being tested. So the language, all the editor features of the language that is being tested are available. So like content assist and hyperlink navigation and validation and so on. But Xpect customizes this editor a little bit, but in a non-invasive way. So the domain model example that I installed in my host workbench is not modified in any way. All the Xpect stuff is declared externally. And right, but now, since we have the editor, let's look a little bit closer at what we actually see here in those tests. And here, for example, let me remove this for a second. What's here between the curly braces is Xbase. It's an expression language. And here in Xbase, the domain model example, where we define a variable with a val keyword, which means it's a constant or a final variable. But here in this test case, we try to assign something to the final variable, which obviously doesn't work. And so a common scenario would be that we want to test that the validation really finds this mistake and flags this mistake. And to do so, we can insert an expect statement. And this expect statement says, I expect errors. So errors is now one of many possible expect cases, expect tests. And the test here is the expectation of the test. So the expectation says that there should be an error in the next line. It's always the next line. And the message of this error should be assignment to final variable. And the location of the error marker should be this one, X. Let's remove this statement again. So we see, yes, the error marker is exactly under X, and the message is assignment to final variable, right? And if I put the expect statement back in place, we actually see that it consumes the error marker. Meaning when the expect statement is in place, then the error is expected. So the editor doesn't need to show it anymore, and the problems view doesn't need to show it anymore. It's quite a basic feature, but it's really, really convenient for developing tests, because when you test a language, of course you need to create hundreds of documents that are broken. And if you load 100 broken documents in your Eclipse, then it's totally polluted with error markers, which we as developer do not want to have, because we only want to have error markers for those problems that we need to fix, not those intentional error markers. Right, so, and here we have, there's two syntaxes for the expectation. One is with the error. One is starting with a triple dash and ending with a triple dash. So this is like a single line expectation. This is like a multi-line expectation. We can assert warnings, errors, all kinds of things. Yeah, so let's, and actually up here in the expect setup test, we needed to tell what Java class is actually running the test. So the Java class is here, and we see it extends validation test, and validation test is from Xpect-lib. So Xpect is also shipping a library of test implementations. So it's like just the test logic, but no documents, no expectation. So we are just reusing the test from the library, and now I can go here to, and this test, we realize based on this annotation, it's actually a JUnit test. So this is org JUnit runners, and Xpect makes use of a custom, or Xpect provides a custom JUnit runner, and which means that I can just run this test as a JUnit test. And if I do so, then here in the JUnit view, I see really nicely that my test executed my test1.xt file and my test2.xt file, and if I do a right mouse click, I can say go to Xpect, and then the Xpect-Editor opens and selects the proper Xpect statement. Right, so that's the awesome scenario when everything is green and we can call it a day. So let's break something. So I will modify a few test expectations here. Just insert some garbage, and then I will run the test again. And now, obviously, 2 tests failed. And now we can see a feature which is really useful in Xpect, because now when I do a right mouse click on the failed test, there's this menu item saying compare. And when I click on it, I get a comparison editor. And in this comparison editor, I see my test. And on the left-hand side, it's the expected test result. So that is the file like it is stored on disk. And on the right-hand side, that is the actual test result. So that is the test result, how the test computed it. So it's like Xpect is kind of like participating in me programming. Like it's really, I don't know, it's like almost sending a pull request to my code base. So like with all those kinds of contributions, I should, first what I like about it is they're really easy to review. I mean, with this diff, you can really see immediately why the test failed. And because the test is not just saying true, false, or I failed or something, but the test is actually computing what is the result. The test is basically explaining to you what really happened. And now, like with all code contributions, I should review them very carefully, and when I agree with what the test computed, I can even use the copy over button from Eclipse. Now it copied over this one, save it, close the editor, run the test again. And now we see that I fixed the first one, but the second one is still broken. But I want to show something else, so I will break the first one again and run the test again. And now I double click on not on the Xpect statement, but on the file. And then we get a comparison editor that visualizes all failed tests from this specific file. So I can just review them in one batch. And that's a very powerful feature to understand why tests failed, and also at the same time, fix them. Right, so there are so much for validation tests. But as I said, Xpect ships a library of predefined tests. So there's quite a bunch more. There are, for example, linking tests. Like here, you can say, I expect the linked name of, all right, this one is nice because here I also introduced a little documentation for the expect statement, which is nice because when I run the tests, and here I can also see the test documentation in the JUnit view. And right, so this linked name test works like this, that it says I expect the linked name of the cross-reference at the location, at this location. And this location is what we find down here. So Xpect just takes the string and tries to find it in this document and finds it here. And this is a cross-reference. So this linking test follows or resolves the target object of this cross-reference and then takes the fully qualified name of this target object, which is this one. And we can do this. There's one test that works with where uses fully qualified names as expectation. But there's another test that uses the EMF fragment URI just as it is implemented for your EMF model. That is because in Xtext it's quite common that E-objects have fully qualified names there, but there are also many E-objects that do not have fully qualified names. So for them, using the fragment URI is useful. And then there are other things, like there's a scoping, reusable scoping test, which is really, really useful. It works similarly to the linking test because it uses the same syntax to identify a cross-reference. So here we say I expect the scope at this cross-reference, and this is a cross-reference here. And as my expectation, I start enumerating all names that are in the scope. So here it's this name and this name, and triple dot is like an asterisk, is like a wildcard, meaning there can be more in the scope, but I don't care about it. I can also use negative markers, so I can say these items should be in the scope, but this one must not be in the scope, and I don't care about the rest. So that's how scopes can be tested quite easily. And then there's a little generator test if you do implement a code generator. So this test, so it basically takes this this example, runs the Xtext iGenerator or iGenerator2 on it, and here in the expectation we see the output of the code generator. However, this also nicely illustrates a risk that comes with Xpect. So the risk being to make the expectation just too large. If this document would be a little bit bigger, the generated code would be much more, and you would end up testing a lot of things that you maybe didn't want to test in this case. I mean, if you look at it, we test that the imports are there, we test that the entity is named correctly, we test that it has a constructor and a second constructor and a toString method and getters and setters and a field, and so I think a good rule of thumb is that the test expectation should easily fit on one screen, maybe even on half a screen. If it's getting bigger, then you're probably doing it wrong and your test will become too fragile. I mean, even though it's really, really easy to update this expectation, having many fragile tests is just annoying. And just like testing the generated output, we can also test the structure of the AST. Here's a test that does it like it. So here we have a little example, and this test AST, it just dumps the EMF model. So it basically takes the EMF model and converts it to a string. So this is an E class, that's an E containment reference, the type of the contained element. Here we have an E attribute and the value of the E attribute and so on. So we can just read how our AST looks like. But this test also has the risk of the previous one. Don't make them too big, it's gonna be fragile. And this test is also a nice example on how to implement the Java side for a test. So here I said there are many tests available, and this thingy AST, that is in fact, it's a Java method. So when we run this test, Xpect executes this Java method, and what the Xpect framework does is nothing but make sure values for those parameters here are available. And for this test, we need two parameters. We need the string expectation. So if we look at side by side, this is actually the string expectation, which is like encapsulated here in this object. And we also want to have this model, this is like the one from the current file. And the implementation of this test is incredibly simple because we don't need to do anything, but we just take the EMF model and use the utility to format the EMF model as a string, and then we have it as a string, and then we say expectation.assert equals, and yeah, assert equals will, just like in JUnit assert, throw an assertion error if the computed expectation doesn't match the persisted expectation. Right, so this way it's really easy to introduce new Xpect tests. Right, and there's a bunch of more tests that come with the library of Xpect, but yeah, in bigger projects you usually end up mixing own tests with predefined tests, and you can also mix tests in the very same file. So here we have an example or actually this one. It works like a test suite in JUnit. So it's just composing several classes so that all those classes can be used, or all those Xpect methods from those classes can be used in the very same file. So that your file can look like this, so that first you do a linking test, and then you do a scoping test, and then you do a validation test. I really like this pattern because it enables you to test individual language features comprehensively. It's like it allows you to structure your test suite based on language features instead of structuring it based on test kind. So for example, you could have one package for validation tests, another package for scoping tests, and so on. But this one allows you, to do it feature-based. Right, and so this is all stuff that has been available for a while. But today I have the pleasure to show something new, which is also now available in the latest version of Xpect, which is you don't need JUnit anymore to actually run tests. I mean, what if we could just open an XT file in the editor, and the editor would inline just run the test and tell me whether it passed successfully, just like validation. So here I have a small test that says, now I'm using the arithmetics example from Xtext, and in arithmetics we can just write down small computations. We can use constant values, plus, minus, and we can also use variables. And here I have an expression which is syntactically not valid. So I say $+5. Dollar is not valid here in this context. And that's why I need to expect this error here. But now if I, let's say, change dollar to something else, then I see that now I immediately see my test failed. So I have live testing. And if I look at the error marker, I see the expect test failed because the actual test result in this text is, yeah, % and not dollar as it is written down. And because with Xtext it's so easy to implement quick fixes, of course I did that. So we can use a quick fix to adapt the expectation of the test. And now it's, yeah, we migrated to %. And this kind of test works for pretty much all Xtext tests that can run standalone. For tests that require a workspace or a workbench, it does not yet work. So here we have more examples about testing the validator of the language. So here, for example, the validator checks if there is a division by 0. And yes, here is a division by 0. So let me remove this expect statement, and we get the error message, division by 0, and then I put it back in place, and now it's being expected. And if the expectation is wrong, then I get this error, and then I can fix it again. And then it's, it works again. And really convenient for testing validators, but works as well for testing scoping. So here we have a scoping test that here we define 3 definitions or functions. Here we do 24 plus x, and in the scope of x there should also be y and z. And now if I add another one, then immediately my test fails, and I can replace it, and oh, there's now also the a inside. But there's still a mistake because the z should also be inside. Or this language also implements an interpreter. So this is now a custom test for this language. Really nice. So in the language I write an expression 1 plus 2, and then eval just computes, hey, it's 3. Or here I have a little definition that computes a square, y times y, and here I have an expression making use of the function, and I test that the interpreter really runs this one. You can see if I change this number, then the result is different. Right, so much for demo. I wanted to show a little bit more. About one thing that I should say, right now I showed that the languages are installed in Eclipse. They don't need to be. Xpect runs very fine also on languages that are in the very same workspace as what you have. So you do not need to launch a runtime Eclipse to run the tests. You can just change your scope provider, run the test, change your scope provider, run the test, or change your validator, run the test. And to run the tests in continuous integration build, you can, it's just JUnit. So it's really, you can use Maven Surefire or Maven Tycho to run the test. Which brings me to the next point. The tests run as well. They run as standalone tests, but they also run as plugin tests. So the very most tests are structured or implemented in a way that they work in both scenarios, like scoping tests or validation tests. But of course, they can also be tests that only run as plugin tests, maybe because they need specific dependencies or because they test some UI capability. So I've seen projects that also, they chose to run those tests twice actually, once as standalone test and once as plugin test, because they wanted to make sure that their language really works in both cases. Right, so we're running out of time. That's the things from my side. Are there questions? Are there things you, yeah? So question was, what's the current state of the documentation? So there are two example projects that serve as documentation. They're inside the Git repositories, so please refer to those example projects, check them out, run them, modify them, play around with them. They illustrate how to use the library, and they also illustrate how to run the tests in Maven Surefire and in Tycho Surefire. And there is a wiki on the Git repository. There's some information in the wiki as well. So the question was about the asterisk or the ... in the scoping tests, whether it wouldn't be better to just list everything. For some languages, yes, it's really good to list everything. But the example language that I've been using makes use of Xbase, meaning that cross-references can point to Java types. So there are cross-references that can point to any Java class, meaning that every Java class on your class path is also on the scope. And that's too much for the test. And also the Xtext Scoping API doesn't even allow to enumerate them all. That's because it's implemented on content assist level, not on scoping level. So I found it useful to sometimes focus on those items that you really want to test there. More questions? So question was, are there recommendations how many test cases should be put into one file? I have to admit it's a little bit of a trade-off. So like for validation tests, it works usually quite well to put many tests into the same file, but the trade-off is when you really need to start debugging them, then of course your debugger state involves the complete file. So conclusion is, if you make your files bigger, debugging can become a little bit harder. So depending on, yeah, so that's why I would say it's okay to put more than one test into a file, but don't make them too very big, because otherwise debugging is unnecessarily complex. Okay. So we run out of time. Thank you for being here, and I will be at the Typefox booth for a little longer. So if you have more questions, please come there, ask me, and I can also show more stuff. Thanks.